Welcome to Theory of Computation class. In this class, I give the overview of minimized DFA and the concepts available in Unit 1. So this minimized DFA concept is only applicable for conversion of NFA to DFA. That is, I already give the first problem instruction in previous class videos. So just to go through the conversion of NFA to DFA. For that DFA resultant table only, you can able to implement the minimized DFA concept. And another one, the second type is, we can also construct an DFA from epsilon NFA. For this, it's not necessary to implement minimized DFA because it is already in a minimized form. So, this minimized DFA only be used for the conversion of NFA to DFA problem only. So, how can we implement those concepts? It contains 3 steps in it. Step 1, first you should identify the equivalent states in the resultant DFA. So, either the DFA may be represented with a transition table or transition diagram. From the table or diagram, you should find out the equivalent states. Then, you should split that states into 2 categories, accepting states and non-accepting states. First, you divide it as accepting states and non-accepting states. From the non-accepting state, you should find out equivalent states and not equivalent states. So finally, you should get 3 different states in it. So after final calculation, you can able to find out equivalent states, not equivalent states and accepting states of the resultant DFA. Then you draw the diagram for this DFA notation. Okay. Then here, this is the DFA table. So this DFA table is retrieved from the NFA. So I already told that it's not necessary to calculate the minimized DFA for the problem epsilon NFA to DFA because it is already in a minimized form. So you cannot able to implement minimized DFA from epsilon NFA to DFA. So you only implement the minimized DFA in NFA to DFA only. Okay, so this is the DFA transition table. So first you refer this table. This contains 2 input symbols AB and 5 set of states are there. So mod Q contains 5 set of states and the number of input symbols are 2. What is the first step for minimized DFA means? First you should write all the states in a single group. Then you split it into two ways. One is not accepting state. Another one is accepting state. Accepting means final state. So from the table, how many final states are there? If any table is given, we can able to find out the final state with the star mark. So how many star marks are available? Only 1 star mark. What is that state name? It is E. Then what are the remaining states? A, B, C, D. So I write it as separately. Okay, here the same thing will be written here. Then from the non-accepting state, you just check whether any 2 states or 3 states combined contains the same output states in it. First you check what is the answer for AA. It is B. AB is C. So first you check whether the B, C answer is available in other states. Yes, it is available in state C. So you can able to combine A and C as same states. So I combine A and C. Next, I check the other states B and D with the same output as available. So if you see, it's not BC, it's not BC. But if you consider the last state E, it is also contain the same answers of A and C. But you cannot able to combine E with these notation because E is splitted already. You cannot able to combine here. Okay, so only I can able to combine A and C as a group, single group. Then you check B. So I am writing B here. Whether is there any other state contains the same output states? No. So B is single. And remaining is D. D is single. E is already splitted as accepting state. Now you check only 2 has one group. So this will be combined as single group. So I am writing the minimized DFA table, the same input symbols A, B, and instead of writing C, I can able to delete this C state. It's not necessary because I already minimized it. So only how many states are there? 1, 2, 3, 4. 4 states are only possible. So I write that state. Wherever C is available, you only write it as A because A and C are same. So what are the values or answers available in the given DFA table, you write the same answers, but instead of C, you write it only A and you remove C state. So this is the minimized DFA table. Are you clear about it? Then, so this is the overview of Unit 1. So we come to the end of Unit 1 session. So I divide this portion as two parts. The first part is the theoretical part and second half is the problematic part. The theoretical part contains the basic concepts of automata theory. So you know about it: alphabet, strings, languages, grammar and graphs. By using these first three notations, we try to implement the problems. Okay, and then proof concept. So theoretical part contains proofs in it. So proofs are majorly categorized as three parts: formal proof, inductive proof, additional forms of proof. This formal proof contains 4 types: deductive proof, reduction to definition, other theorem forms, theorems not in if-then form. This formal proof is only applicable for sequence of steps. If any iterations of steps are available, you should go to inductive proof. This inductive proof is further categorized as inductive method, general form of integer induction, structural induction or structural proof, mutual induction. And additional forms of proof are available, which are all categorized as sets, that is proof by sets, proof by contrapositive, proof by contradiction and proof by counter method. So I already gave the lecture sessions for all these proofs and few problems are discussed in inductive methods also, and also proofs in a tabularized form with truth table. That is also available for contrapositive and contradiction proofs in the previous lectures. You just go through it. Then the implementation of automata theory, it is possible in a machine. That machine is called as a finite automata. So finite automata, it is a mathematical model which contains quintuple representation. That means 5 tuples. Those are all set of states, set of input symbols, transition function, starting state and final state in it. So this will be categorized as 2 types: deterministic finite automata, non-deterministic finite automata. If any question is given as construct finite automata, which means that defaultly it represents DFA only. Okay, then in 2 marks they can able to ask a questions like, they will give the simple sentences and you may able to draw DFA or NFA accordingly. So this will also be given. You just go through the previous video sessions. And the 13 mark problems are 3 methods are available. One is NFA to DFA. Second one epsilon NFA to NFA. Third one epsilon NFA to DFA. So I already given the lecture problems and the theorem explanations for all these 3 methods. And in this session, I give the introduction about minimized DFA. Okay, then this is the proof. That is, if you do the problem of conversion of epsilon NFA to DFA, the answer is equivalent to epsilon NFA to NFA, NFA to DFA with minimized form. So these are all equal. So how can you check means I give the problem here. So I am giving 4 states and Q3 will be noted as final states in which alphabet symbol AB is there with epsilon. So what is the type of finite automata? It is an epsilon finite automata. And you should do 2 methods. The first method, you should convert epsilon NFA to DFA. First you note it out. Then you do the problem of second one. The second one contains 2 parts in it. The A part is conversion of epsilon NFA to NFA. Then the B part is from the resultant NFA, you try to construct DFA and check whether any minimized DFA is possible or not. If possible, you try it out. Then you check the final answer of the minimized DFA from the second problem and also the answer of first problem, that should be equal. So from this thing, you may be confident about the concepts behind the theory of computation. So it's an easy one, you just aware of it. I hope you understand better with this video. Thank you.